All right, we get to graph. So the first thing that I want you to do is fill out this table. It's a little bit cumbersome, but I want you to be thinking about the numbers you are dealing with as we try to figure out what the graph of y equals 1 over x looks like. And this is a very, very important function. So let's get going. 1 over x means basically you're just going to reciprocal what you have. So that means when x is 100, f of x is a ridiculously small negative 1 over 100. When x is negative 10, f of x is 1 divided by negative 10. And then we keep going. Now, I want to take some time to just look at these numbers and think about what that tells us about the graph of the function. And I'm going to start with negative 1, negative 1. Plot that point. It is an extremely important point. And now I'm going to go to when x is negative 2, plot negative 1/2. And then when I get over to negative 3, it's at negative 1/3. Then it's going to be negative 1/4, negative 1/5, negative 1/6, negative 1/7, negative 1/8, negative 1/9, negative 1/10. And I wanted you to think about this to realize what is happening. There's a word that we have used in previous chapters. Something is happening to this graph. What word do you think is coming into play that we've learned this during this class? Yes, asymptote. Can you see that with this especially, I'm trying to help you to see that you have an asymptote, a horizontal asymptote of the x-axis where the graph is underneath the x-axis. And right now I'm trying to draw an asymptote so you can see that the graph is underneath it. And we draw dashed lines when we are making an asymptote. Okay, then let's look at the positive versions of these. So 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 10, and 1 over 100. And let's plot those. So when x is 1, y is 1. Very important point. When x is 2, y is 1/2. When x is 3, y is 1/3. 4, we get a 4th, and then a 5th, a 6th, a 7th, an 8th, a 9th, a 10th. And do you see that we have the same exact numbers but positive? And trying to draw isn't always working out well. And do you see that we're asymptoting again? And I have 100 there to get you to really see that 1 over 100 is really close to 0. But I'm never going to be able to reach 0, no matter how big the positive number is. So that horizontal asymptote that started on the left end also works on the right end. But on the left end, the graph is coming from underneath the asymptote up. And on the right, it is coming from above the asymptote down. Then, I don't know if you could tell what that I was trying to do you know how they do the little microscope thing? Like, let's take this tiny little bit and microscope it out. I can't see any of your faces to know whether you understand what I'm saying anyway. I don't know if I'm alone talking to myself. Anyway, I'm trying to say that I'm taking a bunch of numbers that are between 1 and -1, and I expanded that out to take a look at what's going on with those numbers. So let's go for it. What is 1 over -1/2? You tell me in chat so I don't feel alone. You got it. And then what is 1 over -1/4? Yay. I know at least one person is here. Actually, 3 because I see 2 people visually. Okay. Do you see what the next ones are? What are the next numbers? You can just write it in chat. Good. Yeah. Almost. This one is just the positive. All right. Now, I'm going to zoom in a little bit. And I'm going to start with -1/2, -1/4, -1/6. When x is equal to -1/2, come on, pen, come back to being, there we go. We're down at -2. But when I am halfway there, so here's -1/2, -1/4, another halfway there, I'm all the way down at -4. And then I didn't want to put in too many numbers because it's tiresome, but let's go down to plotting this the best we can. When x is -1/10, I'm down at -10. But it's like so close to the y-axis, it's hard to tell that it's not on the y-axis. And can you see with the numbers, as I'm going from -1/2 to that -1/10, that I am growing my negative numbers into bigger negative numbers? And what graphical formation do you see happening? Another. Yay! Thank you, asymptote. Do you see that this section that I'm showing you right now, this section on the lower left, that it has perfect symmetry going on? I'm going to draw a line of symmetry. Can you see that this is a line of symmetry? And when you think about what the numbers do when you reciprocate, it might make sense why this comes out with such amazing, perfect symmetry. Then when I look at the positive numbers that are these fractional numbers, so when x is 1/2, 1/4, 1/6, 1/8, 1/10, I am getting these points. Closer and closer and closer, but staying positive. So the function 1 over x only exists in quadrants 1 and 3, where x and y are both the same sign. They're either both positive or they're both negative. So we have the graph of 1 over x. It is a beautiful, beautiful graph. Now, do you see that if I look at the domain, it's everything except one number? What one number is not in the domain? Where does the x value of 0 lie? Good question. When x is equal to 0, it's undefined. If I try to plug 0 into that x, I will get 1 divided by 0, which is a problem. Now, theoretically, it's infinity. But infinity isn't a number, so I can't plot it. The asymptotes just kind of show what's happening as I get closer to 0, but I'm never going to be able to actually plug 0 in. So the domain is all real numbers except for 0, and the way you're going to write it is to put the two continuous intervals on either side of the asymptote. And what is the range? Where does it exist vertically? Do you see it's exactly the same for the range? Every y value will be hit, but you will never get 0. As you try to get 0 for a y value, you're looking at x's that are like positive a billion or negative a billion. They're really close to 0, but they're not equal to. Oh, the U symbol is a union symbol, and if you don't use it, I'm okay with that. I'm okay if you just list them. Let's save our conspiracy theories till Wednesday, okay? Oh my goodness, this is going to be quite a week. All right. Now, horizontal asymptote is the equation y equals 0. Vertical asymptote is the equation x equals 0. And make sure that you understand when you start a parent graph that is 1 over x, I want you to start with 1, 1 and negative 1, negative 1. Those are important central points. You can do the manipulation to those pair of points and see a lot of things with the graph. So let me emphasize, look at how those are very center important points. All right, so now what we're going to do is transform the parent graph. So, number 1, what are we doing to the parent function 1 over x to get to 1 over x minus 4? We are going to move it right 4. And that's all we're going to do. So what I recommend you do is start by plotting the points 1, 1, negative 1, negative 1. I would even recommend that you put a little plus sign at the origin, because that's the center of the asymptotes. And then take all 3 of those, move them right 4 units. So I'm taking the 1, 1, moving it right 4 units. I'm taking the negative 1, negative 1, moving that right 4 units. And 0, 0, moving that right 4 units. And the plus moves over here. And then I recommend that you just take that plus and you dash extend it out, and you have your 2 asymptotes. Then from there, I expect that you know essentially what the graph looks like. You've moved the center points. Just do your best in trying to draw what it does. The domain is now everything except for what number? What one number is not in the domain? Yes. For the range, what one number is not in the range? I see it was written down there, 0. Mm-hmm. Then the vertical asymptote is the equation x equals 4. Horizontal asymptote did not change because I only horizontally moved. That will cause something that's vertical to be pushed, but something that's horizontal is just going to be like, and you're moving me how? Because it's already horizontal. Anyway, so there you go. One problem done. Next example problem. This time what's happening? Mm-hmm. We are moving this up 3 units. I recommend that you again start with the main points, 1, 1, negative 1, negative 1, and put a plus sign at the center of the asymptotes. If I am moving up 3, then this plus sign, that's the center of the asymptotes, moves up here, and I can go ahead and just draw those asymptotes out with little dashed lines. And then I can take the 2 points that I know the parent graph starts with, move them up 3 units. And then I'm going to erase the other 2. And then just do the best I can with trying to draw. And there we go. And this time, what is the one number missing from the domain? The domain is missing 0. And what is the one number missing from the range? 3. Good. The vertical asymptote is the equation x equals 0, and the horizontal asymptote is the equation y equals 3. All right, moving on to another example. Now, I'm going to start doing more graphing problems with you where I don't put it in a nice line. So I'm not going to give you, here's 1 over x, now graph negative 1 over x, now graph negative 1 over x plus 3. What you're going to do is you're going to start with the parent graph, then do the multiplication or division issues, then do the addition subtraction issues. The multiplication division can stretch or compress. It can also flip upside down. Addition subtraction just takes that result from after it is stretched and moves it. So what I'm going to do is talk you through the steps you want to take. First, the parent graph. The parent graph has this nice little plus sign at the origin. And we have starting points 1, 1, and -1, -1. And I'm actually going to plot those in blue because there's going to be so much going on that I need to color code this. The only multiplication here is a multiplication by -1. So that's going to flip this upside down. It's taking the y coordinates of 1 and -1 and multiplying them by -1. And so the graphs, and I'm going to erase in just a moment, but I want to first of all do a quick draw of the parent graph. And mind you, this is a quick draw. And then I'm going to put in green this new graph where this is flipped upside down and the other one is flipped upside down. I'm going to erase the parent graph. And do you see that the plus sign is not going to be affected by any kind of multiplication? That center of your axes will not be changed by any multiplication that you do. Then we're going to do the movement. That +3 is telling me to move what way? I'm going to move which direction 3 units? So the +3 is with the x. When it's with the x, it horizontally moves it. There we go. Thank you. We're going to move left 3 units because we always do the opposite when it's horizontal to the operation. So I'm going to take all these special points and I'm going to move them left 3. I'm going to make these be just green to distinguish. Okay, fine. Don't do that. I want to make sure to clarify. We started off with the points in these 2 positions. We flipped them, and now we are moving them. We are moving them left 3, so this moved left 3, 1, 2, 3. This point moved left 3, 1, 2, 3. And the plus sign moved left 3. And then that is where this graph is going to be. So I'm going to erase the previous graph. And I'm going to use blue for asymptotes to distinguish it from the rest of the graph. And there we go. Yay! Not too bad. This is far better than what we had to deal with on Friday. I would say that Friday's work may be like the worst of it, and you've lived it and you're past that worst part. You just need to keep practicing it a bit to get better. And then I need to finish this up. The domain is everything except for x equals -3. The range is everything but 0. Vertical asymptote is x equals -3, and the horizontal asymptote is y equals 0. Okay. And I think this is the last example. Yes, it is. Last example. This time, we are multiplying by 2. So I've got my initial parent graph. My initial parent graph goes through the points 1, 1, -1, -1, and its asymptotes meet at the origin. If I multiply all of their y values by 2, that's going to tell me how the entire graph stretches. It'll give me a feeling for about where things go. So y coordinate of 1 multiplied by 2, y coordinate of -1 multiplied by 2. And the asymptotes are not affected by that multiplication because they are located at 0 positions. And this graph keeps really beautiful symmetry. So I'm just going to gently draw about what this graph, I'm not doing necessarily the best job, but about like that. Okay. Then I just highlighted that -1. What does that tell me to do to the graph? The -1 with the x. And be careful, remember that x always does the opposite you expect. And I still mess that up sometimes if so write 1, and then the -3 moves it. The -3 moves it what direction? Uh-huh. 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 Woo! Yes. So I'm going to take the points, these main points that I have left from the stretch, and I'm going to move them right 1, down 3. Doot, doot, doot. And then right 1, down 3. Doot, doot, doot. And I want to take that plus where the two asymptotes intersect, and I'm going to move that right 1, down 3. So now that I've figured out where things are located, I'm going to erase all the pieces that help me to get to where I am. Good enough. And then I'm going to draw the asymptotes as blue dashes. And the graph itself, I'm going to put in red. And I'm not drawing the most perfect graph. I'm just drawing a decent rendition of it. And I'm going to show you the better rendition. So this is what it actually looks like. And if you go through the center axis, or if you go through where the asymptotes meet, and you go along a 45-degree angle off of that point, do you see that there's actually some pretty good symmetry that I keep going with this graph? It's pretty amazing. And so there are the list of things to wrap it up. And this is like the parent graph of our rational functions. As we learn to graph rational functions, we're going to see that sometimes we have vertical asymptotes and horizontal asymptotes, sometimes we don't. Some of the graphing we're going to have to we can only do with a calculator. And I want you to see some of the variety that's out there with a calculator. But I want to teach you how to do some of the graphing that you can do without a calculator, just to understand better where the numbers come from and how the graph and the algebra equation relate with each other. So we have no quiz today, and that is the end of the classwork. Your next job is to do the homework. You're going to, I realize, anyway, so number one, you get to sketch a graph, have some fun, then sidestep some subtraction and some multiplication. Only one each, that's it, you're done, and then you go back to the graphing and have fun with graphing. So it's not too bad.